Now that we have an understanding of the shell, also called the energy level, the subshell or sublevel within the energy level, we can then further break down parts of the subshell or sublevel according to something called an orbital, which is a more specific region within the subshell where the electron can be found. An orbital can accommodate 2 electrons. And since we now know the main energy levels, the different sublevels that these energy levels contain, and the electron counts of those sublevels, it is easy to note the number of orbitals for each main energy level. The chart on your screen provides specifics. You see that energy level 1 has 1 orbital. You see that energy level 2 contains 4 orbitals. You see that energy level 3 contains 9 orbitals. You see that energy level 4 contains 16 orbitals. And again, given that 1 orbital can contain a maximum of 2 electrons, if you take 2 times the number of orbitals for each energy level, you'll get the totals that we talked about each energy level having. Now, another interesting fact regarding orbitals is the theory of electron spin, which states that the 2 electrons in a single orbital spin in opposite directions on their axis. Now on to electron configuration. Writing the electron configuration of an atom represents how the electrons are distributed in the atom's various sublevels. Also, further along in chemistry, you'll learn more about the importance that the role of electron configuration has in helping to predict the chemical, physical, magnetic, and electrical behavior of various substances. For right now, though, let's start with learning how to write an electron configuration for a given atom. When writing an electron configuration, it is helpful to have an electron configuration chart, and even more helpful to have the periodic table in front of you, since moving left to right from the top of the periodic table displays the pattern that electrons fill each sublevel. Here is that pattern of filling sublevels simply written out in number and sublevel format. And a little side note, as you may have noticed, electrons will fill the 4s subshell before filling the 3d subshell, based on the fact that 4s is at a lower energy level, meaning that the 4s subshell appears before the 3d subshell on the periodic table. Now let's give it a try and write a complete electron configuration for a helium atom. First, we'll determine the number of electrons in the atom from its atomic number. And we see that helium has an atomic number of 2, and in a neutral atom, that means that the helium atom has 2 electrons. Next, we add electrons to the sublevels in the correct order of filling. Helium is in level 1, and it's in sublevel S, and we know that the S sublevel can hold a maximum of 2 electrons. So given that helium only has 2 electrons, the electron configuration for helium is 1s2, 1 representing energy level 1, S representing sublevel S, tied to energy level 1, and 2 representing the 2 electrons tied to the helium atom. Now, let's try writing the electron configuration for the element lithium. First, we'll need to determine the number of electrons in a lithium atom from its atomic number. We see that it's 3. Now, even though lithium is in level 2 or row 2 as you see it on the periodic table, we know that we always start filling in atoms given electrons in the energy level closest to the nucleus. So we would first write down the energy levels and sublevels that appear before lithium on the periodic table. In this case, it's energy level 1, which only has the sublevel S. We know that that holds a maximum of 2 electrons, and so we'll write down 1s2, given that lithium is just a row down, we see that lithium is located in the second energy level, specifically in the S sublevel. So we'll now write down 2s. We know that 2s provides space for a maximum of 2 electrons. However, since lithium only has a total of 3 electrons, and we've accounted for the first 2 electrons by writing down 1s2, we only need to account for 1 additional electron. So we write down 2s1. Altogether, 1s2 along with 2s1s account for lithium's electron configuration. Now there's another way of displaying an electron configuration that's important. It's an abbreviated electron configuration. And this is important because given that there are atoms with many electrons, we would be writing out very long configurations if not for this abbreviated format. And in fact, for lithium, it would look like this. He in square brackets, He of course representing helium, followed by 2s1. Now here's how we got that if you're wondering how on earth helium got into the mix as we write the electron configuration for lithium. Well, the way that we go about abbreviating an electron configuration for any neutral atom is that we first locate the last noble gas to appear before the element that we are configuring. And the last noble gas to appear before the element lithium is helium. So we display helium in a square bracket. And going forward from helium, we look at the energy level or row that comes next. We see that it's row 2. And we know that the first sublevel in row 2 is S. We also know that lithium has 3 electrons. The first 2 electrons were accounted for in the first row, which is covered by displaying He in brackets, which means the only thing we need to write down after He is 2s representing energy level 2, sublevel S, and the number 1 to account for the additional electron needed. He in square bracket along with 2s1 account for lithium's 3 electrons. And there you have it. The basics on energy levels, energy sublevels, orbitals, and electron configuration. I hope you found this information informative.